Do you all know that a contest called the XPRIZE for solving water shortages is currently taking place? It is predicted that by 2030, 40% of the world's needed water will be insufficient. To address this issue, a sustainable method that is cheaper and does not pollute the environment is essential, compared to the current seawater desalination devices. Rising to address this issue is a contest initiated by Mohammed bin Zayed, the Crown Prince of the United Arab Emirates. In the first stage, teams will submit detailed proposals of about 10 pages, and those recognized will have their names announced in June 2025 to proceed to the second stage. In the second stage, a device of 1 cubic meter per day will be operated with seawater for 2 weeks, and a report must be submitted by December 19, 2025. Approximately 20 teams will be selected to advance to the third stage. In the third stage, a device of 100 cubic meters per day will be operated with seawater for 4 weeks, and a report must be submitted by September 2026. About 5 teams will be chosen to move on to the final stage. In the final stage, a device of 1,000 cubic meters per day will be operated on site in the United Arab Emirates for 12 months starting in the summer of 2027. The team that comes in first place is expected to receive a prize of $40 million. In seawater desalination devices widely used around the world today, such as reverse osmosis and multi-stage flash methods, the release of high-concentration seawater into the environment, leading to the emergence of toxic substances and hypoxic areas, has become a significant issue. A paper published in January 2019 in the journal Science of the Total Environment triggered this concern. Consequently, there is an active movement worldwide towards achieving ZLD, zero liquid disposal. It is predicted that by 2027, the market for devices that meet this requirement will reach $9.9 billion. In Saudi Arabia, this issue has also become severe, and the country has declared its intention to develop technology to eliminate the ocean discharge of concentrated seawater by 2030. Our proposed zero-waste disposal desalination ZWD uses 4 main technologies. 1. It performs evaporation at low temperature 20 to 70 degrees Celsius and atmospheric pressure, which is fundamentally different from traditional boiling techniques. 2. It does not use consumables, such as membranes, thus preventing the release of substances like salt found in seawater into the ocean. 3. Its super multi-stage structure within a single stage container unit enables the realization of a cost-effective device. 4. It recycles the energy required for evaporation, eliminating the need for energy required for heating. Hot seawater is poured into the numerous connected evaporation chambers at the lower part of the diagram, where it is crushed to accelerate evaporation. The seawater that evaporates in the first stage is sent to the next evaporation chamber, thus gradually, the seawater that has cooled down due to evaporation is discharged from the right side. The steam that evaporates from the hottest part is carried by the air and sent to the upper heat exchanger. There, it condenses and becomes distilled water while heating pure water called recycling water at a lower temperature. The latent heat of condensation heats the recycling water. This recycling water then heats the low-temperature seawater discharged from the evaporation chambers at the bottom of the diagram. In this way, the heat generated during condensation is recovered as the heat needed for evaporation. Furthermore, seawater that has decreased due to condensation is supplied to the system by extracting it from the sea. At this time, the low-temperature seawater matches the system's minimum temperature, so there is no need to heat the extracted seawater. Overall, there seems to be no heating from outside, and it seems that needed heat is unnecessary. However, in reality, because there is heat loss, it needs to be compensated for. This is a prototype of a 1 cubic meter per day device that will be used in the second phase of the contest. It has been confirmed that it can completely remove salt from seawater and produce distilled water. Next, we will make improvements to create a device with minimal heat loss. We also plan to add a system to collect the salt that precipitates as a solid. If the water supply fee in Tokyo is 200 yen per cubic meter, and using a system that produces 100 cubic meters per day for 10 years can create a total of 365,000 cubic meters of purified water, then the water supply fee would amount to 73 million yen. Therefore, the goal is to keep the total cost of the system that produces 100 cubic meters per day, along with operational costs, below 73 million yen. This system producing 100 cubic meters per day will be used in the third phase. In the final phase, to produce 1000 cubic meters per day, we plan to use 10 units of the 100 cubic meters per day system. Well then, how much can our unique ideas and devices surprise the world? In about a year, we will know the results. We sincerely ask for everyone's support. Our team's website is available in the description. Please take a look.